Hello my dear students, I am Dr. Jithender Reddy, working as Senior Assistant Professor in the Department of Mathematics and Management Sciences, VIGNANA JYOTHI Institute of Engineering and Technology, Hyderabad. In this video, we are going to learn law of natural growth and decay. It is one of the important application in first order ordinary differential equations. In this video, first I will give the statement of law of natural growth and decay. After that, we will discuss few problems on law of natural growth and decay. Let's go to the statement of law of natural growth and decay. The statement of Newton's law of natural growth and decay. The rate of change of amount of a substance at any time is proportional to the amount of the substance present at that time. First, we have to understand the statement of law of natural growth and decay. The statement of law of natural growth and decay, the rate of change of amount of a substance at any time is proportional to the amount of the substance present at that time. We are going to consider x of t be the amount of the substance at any time t. Then according to the statement of law of natural growth and decay, we can able to write the dx by dt is proportional to the x. Left hand side I wrote dx by dt, that represent the rate of change of amount of a substance at any time is proportional to the amount of the substance present at a time. Right hand side I wrote the x, amount of the substance present at that time. We can able to write this expression as dx by dt is equals to k times of the x. Another one is dx by dt is equals to minus k times of the x. This differential equation represent for law of natural growth, law of natural growth. Second one is the represent for law of natural decay. We can able to solve these differential equation by method of separation of variables. The first equation is dx by dt is equals to k times of the x. This equation represents for law of natural growth by writing in the form of variable separable, x terms on the left hand side, t terms on the right hand side. Then we have to write the integration on both sides. Integration of 1 by x is a log x. Integration of k into dt is kt plus log c. This log c we can write on the left hand side. Then we get in the form of log a minus log b. We know the principle log a minus log b is equals to log of a divided by b. According to this statement, log x minus log c we can write log x by c. After that, applying the exponential on both sides, then we can get x is equals to c into e to the power kt. For decay, the differential equation is dx by dt is equals to minus k times of the x. We can write this equation as in the form of variable separable, that is dx by x is equal to minus k into dt. Now we have to write the integration on both sides. Integration of 1 by x is a log x. Integration of minus k dt is minus kt plus log c. This log c we can write on the left hand side, then we get in the form of log x minus log c. According to the same principle, log a minus log b is equal to log a by b. According to the same principle, we can write this one as log x by c. Then apply the exponential function on both sides. Then we can get x is equal to c into e to the power minus kt. The first solution is x is equal to c into e to the power kt. This is the solution for law of natural growth, x is equal to c into e to the power minus kt is the solution for law of natural decay model. These equations are very important when we are solving the problems. Let's go to the first example. The number n of bacteria in a culture grow at rate proportional to capital N. The value of n was initially 100 and increased to 332 in 1 hour. What would be the value of n after 1.5 hours? Initially, there are 100 bacteria. That means at the time t is equal to 0, at the time t is equal to 0, we have the number of bacteria is 100 and increased to 332 in 1 hour. In 1 hour, we have to find the value of n at the time t is equal to 1.5 hour. That means 3/2 hour. Otherwise, we can write the 1.5 hour. Now, first we have to write the given information in the solution. Let n is number of bacteria at any time t. Initially, the number of bacteria are 100 and increased to 332 in 1 hour. We have to find the number of bacteria at the time t is equal to 1.5 hour. That means 1.5 hour. The given data is in the increasing order, so that we have to apply the law of natural growth. In the law of natural growth, we have the equation n is equal to c into e to the power kt. First, we have to find the value of c, then we have to find the value of k. At the initial time, we can able to find the value of c, then at the second condition, we can able to find the value of k. Now, first we are going to find the value of c at the first condition. This is the first condition. We have to substitute these values in the first equation. Then the equation number 100 is equals to c into e to the power k into t values are 0, so that e to the power 0, then c is equals to 100. Now, we have to substitute this value in the equation number 1. Then we get n is equals to 100 into e to the power kt. For this one, we are giving the equation number 2. Now, we have to find the value of k at the second condition. The second condition is at the time t is equals to 1 hour, the number of bacteria are 332. Now, we have to substitute these values in the equation number 2. From the equation number 2, 332 is equals to 100 into e to the power kt there, t values are 1, so that k times of the 1. Then that implies e to the power k is equals to 332 divided by 100, that is 3.32. Then apply the log on both sides, then we can get k is equals to log of 3.32. This is a value of k. Now, we have to substitute this value in the equation number 2. The value of k, substitute in the equation number 2, we get n is equals to 100 into e to the power kt, t into k value. The k value is log of 3.32. For this one, we are giving the equation number 3. This equation gives the number of bacteria at any time t. Now, we are going to find the number of bacteria at the time t is equals to 1.5 hour. Now, we have to substitute this time t is equal to 1.5 hour in the equation 3. The equation 3 is n is equals to 100 into e to the power t into log of 3.32. From equation 3, n is equal to 100 into e to the power t value is 1.5 into log of 3.232 as it is. Then n is equal to 100 into e to the power log of 3.32 whole to the power 1.5. M into log a is, we can write log a to the power m. According to this principle, I wrote 1.5 into log of 3.32 is log of 3.32 whole to the power 1.5. And we know e to the power log a base c is same as a. So that according to this principle, we can write the value of n is equals to 100 into e log cancel. Then we can write 3.32 whole to the power 1.5. We can able to compute this value 3.32 whole to the power 1.5 in the calculator and multiply with 100. Then we can get 604.9, that is the approximately equivalence to the 605. Therefore, the number of bacteria are 605 at the end of 1.5 hours. Let's go to the second example. Bacteria in a culture grows exponentially so that the initial number has double in 3 hours. How many times the initial number will be present after 9 hours? When will it be triple? First, we have to assume that the initial number is capital A. Initial number is capital A, and it has double, that means 2 times of the A in 3 hours. Then we have to find the bacteria at the time t is equals to 9 hours, and as well as we have to find the time t when the initial number will become triple. First, we have to write the given information. Let x is quantity of bacteria at any time t, and we are assuming that initially the quantity of the bacteria x is equal to a at the time t is equals to 0. After 3 hours, they are given the initial number has double. That's why we are writing at the time t is equal to 3 hours, x is equals to ta. Then we have to find the value of x at the time t is equals to 9 hours, and as well as we have to find the time t when the initial number has triple. The given data is in the increasing order, so that according to the law of natural growth, x is equal to c into e to the power kt. We are giving the equation number 1 to this. First, we have to find the value of c at the initial condition. Then we have to find the value of k at the second condition. The first condition is time t is equal to 0, x is equal to a. We have to substitute these values in the equation number 1. Then from 1, x is equal to a is equal to c into e to the power t value is 0, 0 into k is 0. Then that implies c is equals to capital A. Now we have to substitute the value of c is equal to a in the equation number 1. That we can get x is equals to a into e to the power kt. Now we are giving the equation number 2 to this. Now we have to find the value of k at the second condition. The second condition is time t is equal to 3 hours, x is equal to a. We have to substitute these values in the equation number 2. From the equation 2, x is equal to a is equals to a into e to the power kt, t values are 3, so that 3k. A is on both sides, it will be cancelled. Then we can get e to the power 3k is equals to 2. Then apply the log on both sides. Then we can get 3k is equals to log 2. Then that implies k is equals to 1 by 3 times of log 2. This is the value of k. Now we have to substitute this value of k in the equation number 2. The value of k substitute in equation number 2. We get x is equals to a into e to the power kt, k value into t, that is t by 3 into log 2. For this one, we are giving the equation number 3. From this equation, we can able to find the value of x at the time t is equal to 9 hours, as well as we can find the time t when x is equal to 3a. Now first we are writing the equation 3 as it is here. X is equals to a into e to the power t by 3 into log 2. Now we have to substitute the time t is equal to 9 hours in the equation number 3. Then x is equals to a into e to the power 9 divided by 3, 3 into log 2. Then a into e to the power m into log a is a log a to the power m. According to that principle, we can write log 2 cube, e log cancel. Then a into 2 cube, that means 2 cube value is 8, 8 times of the a. That means the initial number has 8 times at the end of the 9 hours. Now we have to find the time t when the initial number has treble. Now we have to substitute this value in the equation number 3. Then 3a is equals to a into e to the power t by 3 times of log 2. A is on both sides, it will be cancelled. Then we can write e to the power t by 3 times of log 2 is equals to 3. Then apply the log on both sides. We know the principle, log e to the power a base e is equals to same as a. So that according to this principle, we can write log of e to the power t by 3 log 2 as t by 3 log 2, e to the power t by 3 log 2 is equals to log 3. Then here e log cancel, t by 3 times of log 2 is equals to log 3. Then that implies t by 3 is equals to log 3 divided by log 2. Therefore, the time t is equals to 3 into log 3 divided by log 2. We can able to compute this value in the calculator. Then we can get the time value t is 4.7. That means the initial number will become treble at the time t is equal to 4.75 minutes. Now we'll discuss the another example. that is radium disintegrates at a rate proportional to its mass when the mass is 10 milligrams. The rate of disintegration is 0.051 milligrams per day. How long will it take for the mass to be reduced to 5 milligrams? First, we have to write the given information. Starting at the time t is equals to 0, there the quantity of the radium is 10 milligrams and the rate of disintegration is 0.051 milligrams per day. Now we are writing this information in the solution. Let x is the quantity of radium at any time t. Initially, the quantity of the radium is 10 milligrams. The rate of disintegration is 0.051 milligrams per day. That's why here we wrote at the time t is equals to 1 day, x is equals to 10 milligrams minus your disintegration value is 0.051 milligrams per day. That's why we are subtracting this value from the original quantity. Then we can get 9.949 milligrams. Then we have to find the time t here when x is equals to 5 milligrams. Here the given data is a decreasing order. At the time t is equal to 0, 10 milligrams. In 1 day, it is a decrease to 9.949 milligrams. So that we have to use law of natural decay, that is this x is equal to c into e to the power k t. We can able to find the value of this c at the first condition. That at the second condition we can get the value of k. The first condition is at the time t is equal to 0, x is equal to 10. We have to substitute these values in the equation 1. Then we can get the value of c. So that from 1, x value is 10 is equal to c into e to the power t value is a 0. So that 0 times of minus k is a 0, e power 0 is a 1, then c is equals to 10. Now we have to substitute this value in the equation number 1. Then we can get x is equals to 10 into e to the power minus k t. For this one, we are giving the equation number 2. Now we have to find the value of k at t is equals to 1 day. This. Now we have to substitute these both values in the equation number 2. From 2, 9.949 is equals to 10 into e to the power minus kt, t value is a 1 here. Then we can write e to the power minus k is equal to 9.949 divided by 10. That can be written as 0.9949. Then apply the log on both sides. Then we get minus k is equals to log of 0.9949. Therefore, k is equals to minus log of 0.9949. The value of k substituting in the equation number 2, then we get x is equals to 10 into e to the power minus k. K value is a minus of log, minus e to minus is plus. Then we can write log of 0.9949 into t. This is a equation number 3. This equation gives the value of x at any time t, and as well as we can able to find the value of t when we know the value of x. Here we know the value of x is equal to 5 milligrams. At this value we have to find the time t. The equation number 3 is x is equals to 10 into e to the power t into log of 0.9949. This is the equation number 3. Now we have to find the time t when x is equal to 5 milligrams, so that we have to substitute this value there. Then 5 milligrams is equals to 10 into e to the power t into log of 0.9949. Then that implies e to the power t into log of 0.9949 is equals to 5 divided by 10. Then that implies e to the power t into log of 0.9949 is equals 5 divided by 10, 1 by 2. That value is 0.5. Now we have to apply the log on both sides. Then we get t into log of 0.9949 is equals to log of 0.5. Therefore, the time t is equals to log of 0.5 divided by log of 0.9949. We can able to compute this value in the calculator. Then we can get 135.56 days. That means the quantity of radium reduced from 100 milligrams to the 5 milligrams in the period of 135.56 days. Here I gave the 3 problems in the worksheet. You should practice them. Then you can able to answer to any questions. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.